Welcome to TutorMate Assignment 2 Review. We have prepared this assignment review for your use in completing your assignment. In this assignment review, we are just highlighting to you the theorems that you are supposed to apply and the questions that you can perhaps perform before you actually complete your assignment. We also want to highlight to you that there is negative marking in this assignment. You will lose 1 mark for each incorrect answer provided. Question 1. The theorem that you are supposed to use is Theorem 2.2.3, found on page 101, and also Table 1, also found on page 101, and Theorem 2.2.4, found on page 104. The exercises that you can complete to successfully complete this question is exercise set 2.2, question number 21, question number 23, question number 25, and question number 27. Question 2. Question 2 also tests you on the properties of determinants. The theorem that you're supposed to apply is found on page 108 in the Theorem 2.3.2 and Theorem 2.3.5, page 110. It states that if A is invertible, then determinant to the power 1, determinant to the power minus 1 is the same as saying 1 over determinant A. And also the transpose that have been included, the answer for you to get on the transpose, you find it on Theorem 2.2.2, page 101. It states that determinant A is equal to its transpose of that same determinant A. Question 3. The answer to question 3 comes from section 2.3, page 106, which says that determinant Ka is the same as k to the power n, determinant of A, where n is the number of rows. In this question we got 4 rows, so your n is equal to 4, your k is equal to 4, your determinant A is equal to 1 over 64. Then the transpose of a square matrix does not change the determinant. Question 4. The theorem in use on question 4 is Theorem 2.35, and also the theorems and the principles as described in question 3. Question 5. The Cramer's rule. The theorem that you are applying is 2.37, page 112, 112, which states that if Ax is equal to B is a system of n linear equations in n unknowns such that determinant A is not equal to 0, then the system is a unique solution. So the option A should have a unique solution for it to be solved using a Cramer's rule. Also, you are supposed to find the determinant of that linear system, use the arrow technique to determine the determinant of the linear system. The arrow technique is found on page 98, example 7. Question 6. Vector in 2 space, 3 space, and n space. The last paragraph. Pay particular attention to the last paragraph of page 121. It states that suppose that V and W are vectors in 2 space or 3 space with a common initial point. If one of the vectors is a scalar multiple of the other, then the vectors lie on a common line. However, if we translate one of the vectors as indicated in figure 3.1.8b, then the vectors are parallel but no longer linear. Then we go to question 7. Question 7, option A. You find your answer on page 131 on unit vectors. Please do example 2 on page 132. Then also, option B. We refer you to the last paragraph on page 135 on algebraic properties of the dot product. It states that in a In a special case where u is equals to v in definition 4, we both obtain the relationship v dot v is equals to v squared. Question 8. Theorem 3.22 and 3.23 on page 136. The concept in the question has not been fully explained in your prescribed text. However, there are questions in the textbook which will indicate to you the solution to the problem. Exercise 3.2, question 17a, page 142, and question F on page 143. Additional material has been prepared for our students and uploaded on the online learning platform. We have prepared lecture slides where we have actually demonstrated how to work these examples, how to work and get the solutions that are in the assignment. However, we do not specifically provide you the actual answer to the question, as this will be in contravention of UNISA regulations. What we've done is to provide you with the material and specific areas where, if you go and check in the textbook, you'll be able to identify the specific answer to the specific given question. For more information, please visit us on www.tutormate.co.za.